for inviting me to speak about requirements for sustainable aviation and shipping. So I tried to get my desktop for you and present my transparencies. I'm from the Federal Environmental Agency, and I'm speaking today about requirements for sustainable aviation and shipping. It is based on a long year study and scenarios and other parts like environmental impacts of power to liquid of other fuels. What is sustainable? If we talk about sustainability, then we have today very different definitions about that. But the UN has defined 17 goals to transform our world. There are boundaries, planetary boundaries, which are important. And last but not least, there is the Paris Agreement, where we have to lower our greenhouse gases until 2050 to zero. All these together are the goals we have today, from environmental goals to societal goals. This is only possible if we completely transform our society from that what we have today, and fossil fuel driven high velocity economy, using up all our materials, using up everything we have, spending more than we have, more than people need. If we would take our resources we need today and give it to everyone on the world, then we would need something about 4 to 10 planets Earth to have the resources we need. So this has to be lowered to create that what we name well-being, well-having, and other things. I will focus, at least on the beginning, on 4 points. What is sustainable change? What are elements of the sustainable anthroposphere? Clearly, it is that we have to lower our greenhouse gases, that we have to be CO2 free. Then we have to look into our water use, land use, and materials. These is that what is very important boundaries of our sustainable development. Looking into the future means that you try to calculate the future with models, with a lot of mathematics, a lot of hard science fiction, I always call it. You look into the future, creating different scenarios, and I'm taking now scenarios which we developed for Germany, scenarios which deliver a greenhouse gas neutral and a resource efficient Germany in 2050. And what we learn from that is that in principle it is possible to be greenhouse gas neutral, that's the scenario Green Supreme, and with this Green Supreme scenario we are able to deliver greenhouse gas neutral Germany. This means that there are developments in certain sectors necessary. One is that we have to look into the interaction between greenhouse gas emissions and raw material use, and I will come back on that. The good part of the story is that it is in principle possible with today's technologies to reach a greenhouse gas neutral Germany. Let's look into the mobility sector. What are the conditions, the rules, and the way to change these these European, this industrialized country scenario? First, we have to reduce our greenhouse gas emissions in the mobility sector by avoiding, shifting, and improving. What I'm doing now is avoiding. No one has to travel. I sent hopefully more or less good tape of my talk, and I don't have to travel. So part of that is avoiding, shifting, and improving. Improving means that our technical system gets better and better. Air transport is very good in that. They have improved their efficiency in the last decades, every year by several percent. Shifting, let's say, into cars, not to cars, to buses and to railroad has not happened really. After you have avoided, shifted, and improved, you have to develop alternative fuels and propulsion technologies, which are really greenhouse gas neutral. Looking into the different modes, you see that power to mobility, direct use of electricity, and power to liquid are the different possibilities to generate a system which is greenhouse gas neutral, more or less. Electricity can be used directly in passenger cars, even in trucks, short haul, but also on long haul. There are some tests running on German streets at the moment, and urban buses also. Rail traffic is long ago electrified. But there are two, let's say, parts of the sector of mobility which have a problem. This is air transport and ship transport. Why? First, if we want to cope with the Paris Agreement, then we have to change very fast the greenhouse gas emissions of shipping and aviation. But shipping and aviation have long living technologies for several reasons. Aviation is a long living technology because it's a security. There's a lot of things which have to be done. So the question we generated some years ago in the Federal Environment Agency and also in other science institutions was, how can we change to other fuel, changing also the management of our flying and shipping. And with these changes, we are able to get in a first step very fast greenhouse gas near aviation. In the second step also something in the shipping. These two sectors of the mobility have a priority of getting these power to liquid. And what is power to liquid? In principle, it's a long known technology since the First World War and later also in South Africa. Countries Second World War in Germany also, tried to be independent from importing oils, and they developed several paths to a fuel made out of electricity from wind and photovoltaic, from water, producing hydrogen, having a CO2 supply. The best thing is having a direct air capture, and then making, let's say, a chemical voodoo and creating out of drops in this case, but there's also a methanol path, a catalytic path also. They produce a power to liquid jet fuel. And this power to liquid jet fuel is chemical equal to that what we have produced, which is produced from refineries today. This power to liquid jet fuel is a solution where we today are able to put in 50%, up to 50% of artificial power to liquid, which is also named sustainable aviation fuel. And I'm talking of that, not of biomass, because biomass is a slightly different path. And the problem of biomass is that, we know that biomass is not enough, because if you look at the land use, which biomass needs to produce the same amount of fuels, there is that much land use that it is not sustainable looking into the 2050 situation. Again, remembering that, let's say from a first view, sustainability is defined by land use, water, greenhouse gas neutrality, and materials. Okay. How much power to liquids do we need? If we take again our rescue scenarios, then you realize that to get a path into the future, we need to supply very fast a huge amount of fuels in international aviation, in international shipping, in domestic transport, and at the end of the day also materials, because chemical industry in 2030 and 2040 has to start to be also greenhouse gas neutral. Today, it is based on fossil fuels, and we need a greenhouse gas neutral chemical industry, and that needs also a power to liquid and power to chemical path. These are results from our scenarios, and it's a huge amount we need. If you look at Germany and other countries, that means that at least we have to import that much energy from different sources that we have also we produce in Europe and in Germany. And there is enough resources worldwide on that. It's something we have to come back if the right places are right. But in principle, if you look on this map, you see a lot of spots all over the world where photovoltaic together with wind energy can deliver enough hours of production so that the costs are more or less, you can survive with that. Cost is a problem, and it's not a problem because there is no cost for the climate change. At the end of the day, we will have to pay it. So the right strategy might be not looking on cost, but looking on how fast can I lower the cost. Achievable mileage, like looking into the different paths, power to liquid and biomass, I want to show that looking onto power to liquid with wind power or with photovoltaics, you get more than 8 times more mileage per hectare of land from power to liquid to wind power using Fischer-Tropsch, or for power to liquid photovoltaics also using Fischer-Tropsch. Looking on BTL and HEFA and alcohol to jet, it's much less. And it gets much worse if you look at the water demand. The water demand of all biomass-based biofuels are, okay, I don't have to describe it. It's huge, factors higher than that what power to liquid needs. So from a first view, it is important that we know that power to liquid, power to chemicals, are something we can produce sustainable, and there is enough potential worldwide to do that. But do we have enough materials? Do we have enough land use? Remembering probably something the majority of people don't know, if you produce a kilowatt hour of wind energy, or you produce a kilowatt hour of energy, electricity with photovoltaic, you need materials. And the so-called rucksack or footprint, material footprint today of 1 kilowatt hour produced with wind energy is 110 grams. And we hope that it is in 2050 only 80 or 90. And this is mainly semi-precious materials, other metals. It's very, very important things. As I know, for giving you 1 megawatt hour of wind energy is more or less 1 ton of copper, and that's not good. If you look at photovoltaic, it's even worse at the moment because no one looks into materials, only when the people are optimizing for energy development. And if you look at the possibility to recycle windmills, I don't need to cover all the problems we have there. That means that we have a problem. We have a problem that probably we have enough solar and wind potentials, but not enough materials, metals and precious and other metals. If we take our ideas of a 100% renewable energy system for the whole world, and if we take the ideas of a 100% energy system based on renewables, and if we take them in a velocity we need to cope with Paris Agreement, then we have a problem. Why? If you install renewable energies, you need materials. And the amount of material is depending on how much materials you need, what is the lifetime of the technologies has, what is the recycling rate, what is that, what you get back. And so you have a wall, a materials wall, and this you have to take serious. Why? If you look at this transparency, you see that this is the copper mark of the future. If we solve the problem or if we try to generate a renewable energy world with that technologies we have today, then you have this huge amount of copper going up. That's the one curve. If you take a better scenario, which has less technologies, where you have better copper use, then it's half of that. But nevertheless, the necessary copper goes up in 10 years by a factor 2, 3, and 4. And even if we have these copper worldwide, and if we have countries, governance, solve the governance problem in such countries, then we will have problems with prices, with recycling. And recycling is not a solution, because if I bury this in technologies which live 15 to 20 years, then the recycling comes back in 15 to 20 years. So there is a task for the wind energy industry to be better in resource use, to substitute with probably aluminium and others, to be more resource efficient. Okay, coming back to the ends of what is elements of a sustainable anthroposphere. I've talked about water, land, materials, and greenhouse gas, and CO2. I want to add fairness. Why? If we talk about power to liquids, if we talk about the change to hydrogen, to green hydrogen, we are always talking about importing them, because Europe will not be able to produce all these energies by itself. But going into regions in the world with a huge potential for wind, water, and photovoltaic, then we have to be fair, because it is not creating a solar color or wind energy colonialism. We have to be on a fair trade, on a fair level with that countries which are the exporting countries of the future. So besides the good story that it is possible to deliver a greenhouse gas neutral future, doing things right, improving technologies good, having the right incentives, we have to be aware that it needs also a fair economy between the countries which are exporting and the countries who are importing these. So sustainability is not only looking into the hard environmental use, it is also looking into societal working conditions, educations, and all these other things. So please, if we talk about sustainability of aviation and shipping, then we have to look on all these things. Thank you. And if there are any questions, please send me an email. You have my email account here, and I wish you a very good conference in the next days. Thank you.
Thank you so much. A great thank you to Harry Lehmann, which I believe for what I believe was a very important and very holistic presentation of how important it is indeed, not only to look at wind turbines, not only to look at where a certain amount of energy comes from, but really look at the whole energy supply chains and to get a picture of what is important for in this sense, sustainable